Hello, everyone, and welcome to our discussion on the Utopia Automation Framework. I am Mark Fitzgerald. This talk is being recorded and will be posted for later viewing on our website. I would like to take this opportunity to introduce Utopia Solutions founder and CTO, Lee Barnes, who will be our presenter today. Good morning, Lee.
Thanks, Mark, and thanks everyone who's joined us this morning. We appreciate you taking the time out to learn about our automation framework. Before we get started, I want to go over a quick agenda. First off, we're going to have a poll question just so we can get a feel for the different roles that we have on the session relative to test automation. I'll talk quickly about automation goals and objectives in our conceptual approach to automation so we can all be on the same page there. And then we'll have a slide or two on what the framework is, and then I'll move on to demonstrating the different pieces and parts of the framework. We should have some time left over at the end for questions and answers. If you have questions, please enter them in the chat window. We have some of our automation engineers standing by. They may be able to answer them on the fly via the chat window. They'll also elevate some for the question and answer period after the session. And then I've set some time aside today and the rest of this week to respond personally to the ones that we can't get to. So please feel free to submit your questions as they come up. So let's move on to the poll question. And really just want to understand what your role is with respect to automation, and I'll be able to maybe tailor the topic a little bit based on what we have in the audience. So I'll give you a few minutes for everyone to respond, and looks like we're getting most of them. So just maybe another second or two longer. All right, so it looks like we have a pretty even split between test automation engineers and those who manage the automation effort. So that's good. Everyone is relatively close to automation. I think we can have a pretty focused discussion. So let's move on and really talk about what is our end goal for automation in the first place, because that's where we should start. And I think if we took another poll question on what the automation goals are, test coverage, increased test coverage, reduced test cycle time would certainly be at the top of the list. We find, though, that looking at the value that your existing testing resources provide and increasing that value is often the biggest byproduct of test automation. Certainly, we're increasing test coverage. Certainly, we're reducing cycle time. But as a byproduct, we're freeing up your resources who understand the application, who understand the business, can add a lot of value in exploratory testing or additional test case definition, but previously had been spending a lot of time executing tedious, repetitive regression tests. So we find that to be a pretty big benefit. Looking at test automation success criteria, right? So what makes automation successful? And certainly we could probably add a couple more to the list here, but we see that it really boils down to three key attributes. First is that your automation solution needs to be reliable. And that really comes down to, can I execute it in an unattended fashion reliably, meaning if it says my test cases passed, they passed. If it says they failed, they failed. If there's some unexpected events that happen to occur during that execution, it does a reasonable job of identifying those and recovering from them to the extent that it can. If we're babysitting our execution, we're really losing a lot of the value. It needs to be reliable. And of course, if the results aren't accurate, we don't have confidence in those results, we're losing a lot of the value there as well. Second, it's got to be maintainable. And again, if we took another poll question and said, what's your biggest issue with respect to automation, probably come back, an overwhelming majority would be maintenance. So we need to reduce maintenance, and to the extent and beyond that we're getting a positive return on our investment. And a big part of that is minimizing the sensitivity of your automation solution to application changes and test case changes. And we'll dive into this on the next slide in more detail, but we found that separating the activity of defining the test cases from the actual automation framework or the automation code goes a long way to improving the maintainability. And finally, it needs to be scalable. All right, so building an automation for a single application with some defined scope is one thing, but over time, how you expand additional scope for that application, or how you extend automation to other applications and other technologies and other activities, you don't want to have to reinvent the wheel from scratch each time. So you want to be able to expand your solution very efficiently. So let's move on to talking about our approach to automation, at least the fundamental concept of our approach, which is separating the test definition from the test execution. And really what that means is it's allowing your test analysts and your subject matter experts to focus on what they're good at. And that's defining test cases and analyzing the results. They know the business, they know the application, they're the best resources to be focused there. On the flip side, we have automation engineers who are very good at understanding how automation concepts and technologies can be applied to testing problems, but they may not be the subject matter experts in a specific application. What we find often is that the approach is to take testers or subject matter experts and try to turn them into automation engineers with varying results, or taking the automation engineers and turning them into the subject matter experts so they can handle the entire process of test case definition, test case execution, test results analysis, as well as maintaining the test automation solution. The problem with that is it creates a lot of rigidity in how you staff that as an organization. If you separate those two activities, you really have the ultimate flexibility. You can have your test analysts, subject matter experts, focus on what they're good at. Automation engineers focus on what they're good at, and you're not tied to the staff being the same set of resources. And if automation isn't core to your organization, then you even have the flexibility to outsource the framework creation and maintenance if that's something that you choose to do. So moving on, I want to take a quick second to give you an overview of what the framework is before I start to show some of the pieces and parts. So at its core, the UAF is really the common denominator of what you need to be successful with test automation, independent of application technology or application functionality. So over the hundreds of implementations that we've done, we've seen things that are certainly dependent on application and technology, and we see a lot of things that aren't. So what we've developed is the core of what you need to implement automation successfully, independent of the technology or the application. The framework itself is developed for HP, UFT, and Selenium. So any technologies that can be supported by those two tools can be supported by the UAF. And at its core, it provides you with a flexible test definition interface. We'll look at that in a minute. Has a common layer for interacting with the user interfaces of those applications. Supports using external data, which is very common in test automation. Handles error detection and recovery to increase the reliability that we talked to. and has a common results reporting interface to make results analysis as efficient and as effective as it can be. What it provides as well is hooks for the automation engineers to develop their application-specific testing components. So whatever you need to do to test and verify the results on your application, the core framework has those hooks to allow the automation engineers to focus on what is specific to your application and your testing objectives, versus worrying about all they would have to do at the core layer. And it's easily supportable for new technologies. So, and probably the best example of that I have is when we first expanded the core framework to SAP, the total time to modify the code, the UI object interaction layer, and to test it was less than a day's effort. Of course, we had to understand what those changes would be and design those changes, so there was upfront work, but the actual changing of the code and the testing of that code was less than a day, and that's really where we understood, hey, we have identified what's common here, and we've proven out the kind of this layered approach to building an automation framework. Let's take a closer look at the pieces and the parts before we move on to a demonstration. So as I mentioned, the core framework has a UI interaction layer. And the purpose of that is to seamlessly handle all the differences across application technologies that you might encounter as an automation engineer. How do I interact with a SAP table versus a web table? How do I handle radio buttons in this application versus radio buttons in that application? That is completely handled under the covers, and the automation engineers just get a nice, consistent way to deal with the user interface of the applications. We talked about the separation of test case definition from the automation code. So the core layer also has an external UI. Well, actually, we'll talk about the test case definition in a second. It has an external UI object definition component. So you can identify or specify your UI objects in Excel. Or if you're using UFT, HP UFT, the object repository as well. But if you're using Selenium, that's very important. There are various ways within the Selenium code you can define your objects. They can be in the test cases. They can be as part of a page object model or other things. We believe defining them in Excel gives us the ultimate flexibility and introduces a lot of efficiencies. And of course, it exposes that user interface interaction keywords to the automation engineers so they can do their job. Speaking of that, the automation engineers have complete control in whatever they build, right? So we are not enforcing a certain type of component, a certain functionality of the components. You can make them as big, as small as you need to accomplish your testing goals. So we leave all the flexibility in the hands of the automation engineers. And then any interaction with the application goes through that common UI interaction, takes that worry away from the automation engineers. Next, we have that test definition layer. So we talked about the separation of the test case definition from the automation code. Out of the box, the UAF supports test definition in HP ALM with the business process testing add-in, or Excel. So whether you have HP ALM or not, we've got a way for you to separate the test cases from the code. As we'll see, the Excel front end sits on top of a simple database, so some of the typical issues you might have with entering your test cases, at least automated test cases in Excel, and have them execute reliably, we've taken some of the opportunity for user error out of that. And I'll show you some of those built-in features that we have there. Finally, if we're going to run these automated tests unattended, and that's certainly the goal, we want to be able to understand what happened. All right, so everything from a results perspective, a logging perspective, goes through a common reporting layer. The UAF has a built-in HTML report that allows drill down from highest summary level to the lowest level of detail. Also spits out an Excel summary level report. And of course, if you're executing from HP ALM, results are reported back there in the way we're all used to. The reports, the results themselves first get into a common XML layer. So if you need to adjust the format or suck the results into a different medium, a different system, that's certainly that capability is certainly there. So all the results go through to a common XML layer. And similarly, actually, in the test definition, before the test cases are consumed by the framework, they are transformed into an XML, a common XML layer. So if you wanted to use something other than Excel or HP ALM, you certainly could, as long as you can get the definition of the test cases down to that XML format. So that ends the Death by PowerPoint section of the webinar, and we're going to move into more of a demonstration that I will not show anything executing. I think that's a complete waste of time, but I will show you the different pieces and parts that make up the framework. So I really want to show three use cases. The first use case is I'm an automation engineer and I'm building application-specific components on top of the UAF. The second one is I'm a test analyst and I'm building test scenarios and a test run for the purpose of executing an automated test. And then the last one is I'm again a test analyst and I'm going to execute a test, an automated test run, and then evaluate the results. So first we'll talk about, as an automation engineer, how do I build application-specific components? And I mentioned that we use an external UI definition file. Again, if you have HP UFT, you can use the object repository. We feel there's a lot of advantages to storing this externally, and it definitely, if you're on Selenium, it provides essentially an external object definition capability out of the box. There's no limits on how you break up your object definition. It can be on one Excel sheet, it can be across many Excel sheets. And what is defined here is the object descriptors, which are essentially the properties we use to define the objects. Any way that any properties that you can use in UFT are available here. Any method of identifying objects in Selenium as well are supported here. Mapped to those object properties are the actual name, logical name of the objects that the automation engineers would use to refer to them in their code. We've added one feature that we found over the years really helps the flexibility. Rather than referring to the objects by the object hierarchy that the developers built into the applications, we refer to them by what we call a context. And this is completely up to the automation engineer to define their own context. It allows them essentially to group their objects in any way that makes logical sense within the context of what they're trying to accomplish with automation. So you're not completely confined to how a developer defined the hierarchy of the objects. You can add them to different contexts. You can have them all in the same context. And then when the automation engineers refer to them in their code, they refer to them via notation of context.objectName. All right. Moving on to taking a quick look at the code. I just want to give you a quick taste of what it would mean to build an application-specific component either in UFT. I'm going to show UFT. Same concept applies in Selenium. So I'm going to just do a login component because you don't want to watch me type for hours on end. Just to show you the steps that are involved. So the UAF has a component class template with a component template already there. It handles all the information in terms of the logging and the reporting. That's all done for you. You just simply need to define your component name, any parameters that are required, and then type or enter your application functionality. So in this case, I'm logging in. I'm setting the value of the login.username field to whatever was passed to the function. For any UFT people out there, you'll recognize that this is a custom function, right? We're not using the native methods to UFT, and that's what that object UI layer does. All right. So I call the setText function, and under the covers, it handles making sure that the username field is available for typing it. If there's any differences between different types of edit fields across application technologies, those are handled seamlessly as well. I just have to know as an automation engineer what that UI layer keywords are. All right. So then I would continue to type, entering the password, continues to type, clicking the OK or the submit button, and then I would be done. All right. Obviously, that's a very simple example. You are free as an automation engineer, and for those automation engineers on the call, we know that these components can be quite complex depending on what we're trying to accomplish. You have the ultimate flexibility to do whatever you need to do inside this template. All right. And between the logging that's built into the template, as well as the additional capabilities that are built into the UI layer, a lot of what you would normally have to deal with as an automation engineer is taken care of for you. And of course, there's other logging functions built into the framework that you may need to call as part of your application component. Maybe you're looking for a window to be there. It's not. You need to log an error message. So that all the things that you need to do as an automation engineer are there and supported. I mentioned that the Excel front end was driven by a simple database. So the last step after you create your application-specific components is to import them into the database, the definition of them. So the name of the function, the parameters, any rules about those parameters, and we'll see what I mean by the rules about the parameters when I show you the Excel front end here in just a second. But that's it. Obviously, the devil's in the details about what goes into that application-specific functionality. But the details of dealing with the application's interface and logging and other things, those are taken care of for you. All right. So moving on to the use case where I'm a test analyst and I'm building a test scenario and a test run. So as I said, we can build test cases in HP ALM using business components. For those of us that have HP ALM, I'm not going to show that. We know what that looks like. There's really nothing different about that in the way we support you creating test cases in ALM. We have added a couple custom components to better handle, we believe, looping and iterations in HP ALM. But other than that, everything is exactly the same. All right, so let me show you an example of an Excel front end for for defining test scenarios. So each Excel file is a test scenario. It can have one or more test cases, and those are denoted in red. Each test case can have one or more test steps. Those are formatted in blue. And by the way, all this formatting is automatic. As you create your test scenarios, you do not have to supply any of the formatting. And then each test step, which points to one of those application-specific components that the automation engineers built, has parameters if applicable. And one of the features that we added to improve the the test analyst experience and to eliminate data entry errors is that as you choose a function name or type of function name, it will automatically highlight the number of parameters required for that function, as well as prompt the user with what that parameter is and any rules about how it should be entered. If there's a formatting rule, or maybe there's a list of available options that you can select. All right. So that's all built into the framework. Anything that you can do in Excel to make your life easier is supported. So let's say I wanted to just copy a test case. I certainly could do that and paste it down here. All right, the framework, it didn't break anything, the framework will work. If you wanted to enter them by hand and just type in because you knew all the different functions, you could do that. We've also added a custom ribbon for the UAF with a couple simple buttons to add a test case, add a test step, and I'll talk about loops in a minute. So you can do that yourself. Each test step, in addition to a function name, has an application and an area. The application is what is just that. It's the application that you are testing. The application area is just a way to organize your test steps or your application-specific components in a way that makes logical sense. So typically by application functionality, functional area. And then finally, you can choose a function name. When that happens, you can see that the parameters were automatically populated based on the function that you selected. Another feature of automation is the on-fail directive, or another common feature that automation solutions should have is an on-fail directive, and we support that. So we direct the framework what to do if a step were to fail, and we support end test, so end the execution completely, end the current scenario, and if there's other scenarios, you go on to continue with those, end test case. So if we're on this test case, we just skip down to the next one. And then we'll talk about loops now. If we're in a loop, we just end the current iteration. So we've got a lot of flexibility in what you tell the framework to do if an issue is encountered. Last thing I wanted to talk about is loops with regard to this. Very common automation need, right? I want to do something repetitively, but I want to use different sets of data each time. It just screams for automation. So rather, if you wanted to create 10 new orders, rather than have you put 10 lines in the scenario and fill in the data individually for each one, we've built in the concept of loops. So we just add a begin loop and an end loop line to the scenario. Anything in between those two lines is what it becomes part of that loop and is iterated over. We define the data file that we read from in the begin loop statement, and we define the number of iterations and also the data row that we want to start reading from inside that data file. The only difference at the test step level is that instead of constant data, literal constants, we are referring to columns in an external data file. All right, and the angled brackets tells the framework, hey, don't type this value, go to the data file that was specified in the begin loop statement and read the data from there. So the only thing that you as an engineer need to make sure exists, or a test analyst probably more appropriately, is that the column names in your external data file match the parameter names in angled brackets. Framework takes care of everything else. Okay. I mentioned that we can string as many test scenarios together as we want, and that's done in a run file. Let me show you a run file quickly. Run files is just that. It links together or chains together test scenario files. Test scenarios have run flags, so if you want to, you can turn off whether a specific scenario can run or not. We can also, and this is a key feature that we found over the years is very helpful, you can pass custom properties to your scenario file. You see here we've got a smoke test, just the same scenario that we want to execute across multiple mobile devices. All right, so we've created a custom property called device, and we do that just by literally typing device up here. And then that property, device equals, in this case, Galaxy SX, or S6, is passed to the scenario. And then, of course, the automation engineers have created the appropriate components to make use of those properties. All right, moving on to, one more thing that's a key component for test scenarios is the concept of execution context, or what we call execution context. It's very common, right, if you're interacting with an application that creates user or system-defined or dynamic data, you need to capture that data and use it somewhere downstream in your scenario. So example, when I create an order, I'm probably going to get a system-defined order number. So we have the concept of an execution context, which allows the automation engineers to build into their components the ability to save data off to a variable. So you can see here the last parameter for the new order step is a variable to store the order number. If we ever want to retrieve that, we simply specify that order number in curly brackets, and that can be for any parameter at all, and the framework automatically knows, hey, I need to go grab the value stored in that variable. All right, moving on to the last use case before we start taking some questions is I'm a test analyst, and I'm executing a test run and analyzing results. So we've talked about the run file. The test analyst puts together their run file, and they start either the Selenium execution or the UFT execution. Any way that they prefer. We prefer to not require that the test analysts be experts in either tool and understand how to run them, so we provide kind of an automated way to do that, and I think that's a pretty common practice, independent of how you've structured your framework. So let me show first how we analyze results. And I'm going to show you the HTML output first. The key here, right, after you've set up your run file, you've executed your results, hopefully unattended, you need to find out what happened. The framework spits out an XML file, and then the XML file is transformed into the HTML report. This particular report gives a start time and a duration. It tells you the total number of passed and failed test scenarios, and then the opening state is showing you all the test scenarios that were executed. Red is failed, green is passed. So as a test analyst, I don't care about the green if my test suite is reliable because it passed. But I do care about the red, and I need to find out what happened. Do I really have an application issue, or is there something environmental that caused the execution to fail, or maybe there's something wrong with my test case or data. So in order to find the issue, you essentially just follow the red. And it will expand down to the point where you can see here we logged in successfully, but we created a new order and something wrong in that process. We've got a pretty detailed message. Our automation engineers did a good job of putting a detailed message out there, and I see that I was looking for an item in a list, and that item I was looking for wasn't there. Anytime that there is an error or a failure, the framework will take a screenshot, and that's the default configuration. That is configurable as well. You can turn that off, make it so we get screenshots all the time, only on errors or failures, or turn them off completely. The little screenshot icon, click on that, and it will show you the screenshot that was taken, that was caused to be taken due to that specific error. Each entity in the report has properties. So at the test scenario, and they vary by the type of entity. At the test scenario level, we show the start time, the duration, the number of passed and failed test cases within that scenario, and then any custom properties that might have been passed to the scenario. At the test case level, again, we have start time, duration, but this time the number of passed test steps, passed and failed test steps, as well as if it had a loop, the number of passed and failed iterations. So if we drill down here, we see that we log in, we perform a loop, and then we close the application. The loop contains each iteration independently, and we can see specifically what happened at the lowest level for each iteration. At the loop level, we can see what data file was used, how many iterations were defined, and where we started reading from that data file. Similarly, on each iteration, we see what data file specifically applied to that iteration, as well as the start time and the duration of that iteration. All right. In most cases, the HTML report is enough because it has the summary level, but then the ability to drill down to the detailed level. There's also an Excel level summary report that is produced, again from the XML file. It looks very much like the scenario file, except that it has any loops that exist kind of already blown out for you, so you can see what happened in each individual iteration. And of course, we have columns added for pass, fail, start time, duration, and then a step-level message that was executed. You can see if we refer to an external data file, that data is already blown out in the report. And if we use the execution context, we see what variable was read or what value was read from that execution context. If you're executing from HP-ALM, of course, the pass-fail results at the step level are passed back to HP-ALM, and the results appear there as normally. We also attach any external files that were generated or used to the run record, so you have a history of what happened and what data was used during that run. All right. I'm moving toward kind of the next steps here and what how do you acquire, right? We see a lot of questions popping up, and certainly the most common ones. So how do I get the framework? So it's not a commercial product, but it's certainly real and certainly has been in place in a lot of different organizations. So it comes along with our services. So you engage with us, we bring the framework, we implement it. It stays behind, it's yours, you own it, and and you're free to maintain it. We can maintain it, or someone else can maintain it as well for you. So it is one of our bags of tricks that we bring along to make the implementations that we do and you do much more efficient, and really get you from zero to automation in the right way. So moving on, we have questions and answers. So I've got, I believe here, some questions that have been elevated from the chat window. So thank you for submitting your questions. Okay. So this first one, how much time does the framework save on new automation implementations? So it's a great question, right? Obviously, the question is really what's the value here? And the answer is it really depends on the implementation or the scope of the implementation and the skills of the automation engineer. But if we look at just the core functionality that comes with the UAF, it would take a skilled automation engineer hundreds of hours to implement that, assuming they had a detailed design, assuming they knew exactly what they were doing and they were just kind of implementing that design. But what really happens, right, if you're doing this yourself, is that you go through this trial and error type of evolution. So to get from from zero, from scratch, to where the UAF is today, it could be thousands of hours over a really significant period of time if you kind of evolved that through that process naturally. And then the other aspect to look at time savings is from the perspective of automation engineers. And that's building application-specific components. And we see a reduced effort, of 40 to 50% compared to if they had to deal with all the different complexities of interacting with the different user interface issues, and building the reporting layers and all that. So it's a pretty significant time savings from that respect. All right, let me grab another question. And please continue to ask them if any follow-on questions as they come up. If we don't get to them today, I will follow up personally. So here's one that's a little bit more technical. How does the framework handle different object types without having to change code? So I will assume by different object types you're referring to different application development technologies. So a table in SAP versus a table in a browser. So the UI interaction layer that we talked about exposes one set of methods, right? For example, select cell. So the automation engineers would specify select cell if they wanted to select a cell in a table. And the differences between tables in two different technologies are handled under the covers. So maybe the first row is row 1 in one technology, but the first row of a table in another technology is 0. Maybe the different properties of the tables are different. That's all handled in that UI interaction layer. So all you have to worry about is select cell from the object name and the specific cell that you want to select. So very good question. Okay, so here's the next question. I've had a bad experience with separating out the test cases from the automation code into Excel. The testers were not consistent with data entry and made a lot of errors. Okay, that's more of a statement, but not a question. But it is an important point that I'd like to address. As I showed earlier, the Excel front end has measures built in to help reduce the data entry errors. That's step one. But really, we had success with this approach even before we added those customizations to Excel. And the key really was to work with the testers, so the automation engineers and the testers, to understand what application testing components should be created in the first place and what those components needed to do. And it's not just a one-way street. The testers, we don't assume they know how to design components, but they do know what they want to do from a testing perspective. And then the automation engineers can provide feedback into how those components can be designed. And by the time those components are created and we've gone through this process, the testers really have a good idea of what's there, and they just have to learn the details. And over time, they pick it up pretty quickly, and the less interaction, less support is required by automation engineers. And we found also that it's an important step is to make the testers, whoever's responsible for creating those test scenarios, make them responsible for making sure those test scenarios execute successfully before it's made part of the regression suite. And this ensures not only that those scenarios are correct and they'll execute, but it also accelerates the test analyst's ability to troubleshoot any issues they might encounter along the way. Certainly there's more support required from automation engineers in the beginning to make that happen, but over time, and really a relatively quick period of time, that support really is needed less and less. Okay. Additional question. I'm afraid my leadership will see automation as a silver bullet. How much change can I promise them? Well, I think we could all agree, right? Automation has been seen as a silver bullet for years and years and years. It all comes down to managing expectations. As an automation engineer, you need to educate your leadership on the fact that automation is an investment, and there's realities associated with it. There's technical aspects to it. There's process aspects to it. There's organizational aspects to it. And even the best framework, whether it's ours or yours or someone else's, is going to fail if you don't have those organizational, those process, those environmental attributes in place that all support successful automation. And the fact that you need to build the solution and maintain it, it's an investment, and that's an ongoing cost. And you need to measure it to make sure that your ongoing cost is actually providing that benefit that you would set out to gain in the first place. So, and I would suggest that those expectations, those conversations be had before you start to make that investment, because if those conversations are had after the fact, it's a little bit more difficult to change and reset the expectations, certainly. Please feel free to contact me at any of these methods. We've also set up a landing page, utopiasolutions.com/UAF, and you can enter your questions. There. Again, this webinar has been recorded. It will be published on the website, and I will, as I said, I'll get back to any questions that weren't answered over the next day or two. All right. So I want to thank everyone for taking time out today to attend the session. Hopefully it was educational, not just learning about our framework, but discussing issues and concepts around automation in general. And again, thank you, and enjoy the rest of your day.